Alright, so welcome to my week 7 problem 1 video explainer. So in this problem we are dealing with a prankster who uses a subwoofer to excite the harmonics of a 14.3 meter long hallway, and it's important to note that it is open on one end and closed on the other, and we are taking the velocity of sound and air to be 343 meters per second. So before we start off, we can look at the known variables. So the length of the hallway with the subwoofer will be 14.3 meters. The velocity or the speed of air, the sound in air, is 343 meters per second. And I just kind of quickly drew just a depiction of this scenario with the node being on the left side and the antinode being on the right side. That distance L and the wavelength over 4, which is going to equal L. And we're going to eventually be using that to help us find our frequency. So we know that that distance is going to be equal to lambda, or the wavelength, over 4. And that is going to be because we are solving for the lowest harmonic. We'll get to the higher order harmonics in the second part. But so due to the fact that this is the lowest harmonic, we can deduce that the wavelength is going to equal to 4 times that distance L. So now that we are trying to find the minimum frequency, we know that the velocity over the wavelength is going to give us that answer. And we've already found that the wavelength is equal to 4 times that distance of the hallway. So plugging in the variables that we know, we get the speed of sound and air, which is 343 meters per second, over 4 times 14.3 meters is going to equal 5.996 hertz, which will be the frequency of the lowest harmonic. So now jumping into the higher order harmonics, we're going to follow a similar process. However, it is important to note that we will be adding to that that initial value for with the wavelengths. So previously we found that the length of the hallway is going to be equal to lambda over 4. And now, since we are dealing with more harmonics, we will be adding lambda over 2, which will be giving us that lambda is going to be equal to 4 over 3 times that L, the distance of the hallway. So now we can find the second and third harmonics, and we can kind of see a pattern here that we will just be multiplying that the lowest harmonic frequency by 3 and 5 for the second and third harmonics. So we can deduce that the higher order harmonics will be 3 times that first frequency, 5 times that first frequency, and 7 times that first frequency, that being of the lowest harmonic. And just after multiplying those out, we find that the 3 higher order harmonics will be 17.99 hertz, 29.98 hertz, and 41.972 hertz. And the last part of the problem asks us whether or not any harmonics are close to 18 hertz. That is said to induce a spooky feeling, and that will be yes, because that 17.99 hertz value is very close to 18 hertz, the value that we were looking for. So yeah, some of the tricky parts were for the higher order harmonics, just knowing what to add to get to ultimately get the wavelengths, just knowing what to add, and yeah, just ties what we were doing in class. Kind of mentioned some stuff about superposition, and just more about wavelengths and harmonics. So yeah, thank you.